points A, B, and C lie along a line. If BC is 4 times AB and R is greater than 0, what is the value of R plus T? Let's plot this and let's see what happens. So we've got minus 3, 5. So approximately here, minus 3, 5. And that is A. Then we have 0, 7. So let me label them first. Okay, so 0, 7, approximately here, I think. All right, so we're going to label that 0, 7. And then we have C is RT, okay? And R is greater than 0. And do they tell me anything about T? Well, they're all along the same line. Okay, so that helps. So let's just say that line is something like this. I have no idea, but it's a straight line like that, right? It's supposed to be straight. And then this RT is somewhere along that line. So BC is 4 times AB. Okay, I got it. So that means this probably needs to be extended. So from B to C, so if C is here, let's say, if that's C, R, and T, then BC is 4 times AB. Okay, I got it. So that shouldn't be that hard to figure this out. You just have to kind of look at how much did it go up by and how much did it go, I guess, to the right by. So to get from A to B, we had to go right 3, right? We had to go from minus 3 to 0. So since the distance from B to C is 4 times that, we have to go 4 times that distance that we went from A to B. So instead of going 3, we'd go 3 times 4, which would be 12. So that pretty much means that we are at 12. So C is 12 something. Okay? By the same logic, we're going from 5 to 7, right? So we went up by 2. So from here to here, we'd go up by 2 times 4. Because remember, 4 seems to be the magic number. So we're going up by 8. So what would be the y-coordinate then? That means, let's see here, from here to here is 5. From here to here is 7. So 7 plus 8, so 15. 15 is the y-coordinate. So there you go. Just a little bit of plotting is enough. And then they want r plus t. Well, r plus t would be 12 plus 15, which is 27. A Katende number is a 4-digit positive integer where the first 2 digits and the last 2 digits, in order, form 2 integers that are increasing consecutive multiples of some positive integer. For example, 2025 is a Katende number because 20 is equal to 4 times 5, and 25 is equal to 5 times 5. Also, 2346 and 2324 are Katende numbers. How many Katende numbers are there that are greater than 2400 and less than 2600? All right, so let's figure out some systematic approach here. 2400 is the one boundary, and the next boundary is 2600. So before we get into this, let's actually discuss this just a little bit as to what exactly is a Katende number. So let's just look at the examples. That should be sufficient. So 2025, why does that qualify? Well, they explained it. They say, well, 20 is a multiple of 5, and so is 5, but it's increasing multiples. So they explained 4 times 5 and then 5 times 5. What about 2346? Why does that qualify? Well, 23 is a multiple of 23, 23 times 1. And 46 is also a multiple of 23, but it's 23 times 2. So it's consecutive multiple. And then how about 23 and 24, that number, this guy right here? Why does that qualify? Well, I think because this is 1 times 23, or actually another way of thinking about it would be, let me think about this. Yeah, I think that's right. 23 times 1, and then this number is 24 times 1. So they're multiples of 1. Or this was multiples of 23, This is multiples of 5. So I hope you guys understand. Okay, so now let's tackle this. So we want Katende numbers. So the good news is that all of these numbers in here that we find are going to start with either 2, 4 something, or they're going to start with 2, 5 something. So let's do that one, and then we'll do that one. Okay, so for a number to qualify with 2, 4 as its first two numbers, the next two must be some multiple of, well, obviously 24, but also a multiple of a factor of 24. So, for example, let me just list the factors of 24, and that will probably make a little bit more sense. So what are the factors of 24? 24, obviously, 12, 8, 6, 4, 3, 2, and 1, correct? Yeah. Okay, so let's go back and see. Let's tackle these one at a time. So if we're going to look at 24, 24 times 1 is this 24 guy. And then 24 times 2 has got to be the next one, which is 48. So there we go. We got one such number. Now let's use 12. 24, that's 12 times 2. So the next number has to be 12 times 3, which is 36. There you go. We have another one. So hopefully you understand the process. Let's keep going here. So this 24 is for A to be 8 times 3. So the next one has to be 8 times 4, which I believe is 32. 24, 32. Okay. Next one, using the 6. This one is what? 6 times 4. 6 times 4, so the next one has to be 6 times 5, which is 30. Okay, that's going pretty good so far. Let's use 4. So 4, that's 4 times 6, so the next one has to be 4 times 7, which is 28. So this is another number. And then the next one is 3, so 24 is what, 8 times 3? So the next one has to be 9 times 3, which is 27. 24, 27. 2, that's what, 12 times 2? So the next one has to be 13 times 2, so 26. And then finally 1, well, 24 times 1, so the next one has to be 25 times 1, so that's 25. Okay, so we got 8 there. So let me put 8. We have 8 Katende numbers that begin with 2, 4. All right, so let's do the exact same principle for the ones that begin with 25. So the first thing we got to do is look at the factors, just like how I did here, of 25. So the factors of 25 are 25, 5, and 1. So a little bit less work this time. So 25 and then something. So this is 25 times 1. So I guess this is going to be 26 times 1. So there we go. 5, if we use the 5 as a factor, 25 is a 5 times 5, so the next one would be 6 times 5, so 30. And then finally, the 1, 25 is 25 times 1, so the next one would be 26 times 1, and that would be 26. So that looks like another 3. So that's another 3. And therefore, how many contending numbers are there greater than 2400 and less than 2600? 8 plus 3, and the total, therefore, would be 11. 11 is the answer. Amir, Bay, Cindy, and Derek divide n coins between them so that each receives a whole number of coins. Amir receives 1/3 of the total number of coins that Bay, Cindy, and Derek receive. Bay receives 1/5 of the total number of coins that Amir, Cindy, and Derek receive. Cindy receives 1/7 of the total number of coins that Amir, Bay, and Derek receive. If n is less than 100, what is the largest possible value of n? All right. So, interesting here. Where do I begin? Well, the fractions they've given me are 1/3, 1/5, and 1/7. So the number has to be divisible by all of those. Yeah. Because we're talking about whole numbers, right? Yeah. So then whatever n is, it has to be divisible by 3, by 5, and by 7. Or I wonder if even that is true. Let me... Maybe that's not true. Okay, well, let me try a different approach, because I don't know if that's going to help. Let's just do the way that they're kind of approaching it, the meaning in terms of the sentences. So I don't know. Let's try it. So the first sentence is that Amir receives 1/3 of the total number of coins of B, C, and D, right? So if the number of coins is n, that has to be equal to everything. So let's see here. What will we get from the first sentence? Amir receives 1/3 of the total number of coins. So if these three people total k, this would be k divided by 3. And therefore k over 3 plus k is n. So therefore n would be top and bottom by 3, 4k over 3. Correct? 4k over 3. Yeah. Yeah, I think that's the right approach. And then k would therefore be 3n over 4. Okay. I think that is I think I was on the right track. I just have to make sure that I'm calculating it for k perhaps, but let me just keep going and then we'll figure this out. All right. I think I know what I did. It's not the n is divisible. We have to concentrate on this kind of a number. Okay, I'll explain it in more detail. Let me just go through all this. Okay, next sentence. The next sentence says that Bay receives 1/5 of the total number of coins of Amir, Cindy, and Derek. So if Bay receives, say, let's use a different letter this time. It would be, let's say Bay receives M, this guy. Then the other ones, hold on. We have A, B, C, and D. These three combined would receive, that's M actually. So Bay would be 1/5 of that. So Bay would be M over 5. Okay, that's the right way of doing it. So therefore M over 5 plus M is also equivalent to N. So therefore that's 6M over 5 is N, and therefore M is equal to 5N over 6. All right. So we're making some good progress here. And let's see if I can keep this all on the same screen. I think I can. So the next one, the last sentence that they gave me, is that, let's see here, Cindy receives 1/7 of the coins of the other three. So Cindy, let's say the other three, let's use a different letter, let's use J. And then Cindy would be J over 7. So that means that J over 7 plus J is also equal to N, and therefore that looks like 8J over 7 is equal to N. And I'm running out of space, so let me just do it here. That means that J is equal to 7N over 8. Aha, okay, I now can revisit what I was trying to do up there. N is divisible by 4, 6, and 8. That is correct. Yeah, I think I jumped the gun. Like I went too fast and I wrote something incorrect, but that's okay. When I explained it to myself, it makes more sense. Okay, so we have to find a number that's divisible by both 4, 6, and 8, and they've helped us out a lot. They've told us that it's less than 100, and they want the largest possible. Okay, so that shouldn't be that hard. A number that is divisible by 6, 4, and 8. Okay, well, let's see. let's first multiply those four numbers and let's see what we get. So if we do 4 times 6 times 8, that's going to be what? 192? Yeah, 24 times 8, right? Well, that is a good number. It's divisible by both 4, 6, and 8, but it's not less than 100. Okay, how about if we take half of that? That is, but is 96 divisible by 4? Yes, it is. Right? Because 96 divided by 4 is 24. Is 96 divisible by 6? I think so. It would be 16. And then finally, is 96 divisible by 8? And I also think it is. Yes, 12. There you go. So a little bit of trial and error. You will get 96. But the most important part was to figure out what n is divisible by. So 96 is the answer. A circle A has area A. A regular octagon has area 1/2 A. A regular dodecagon has area 1/2 A. The circle has a radius of 3,000. The distance from the center of the octagon to each of its vertices is x, as shown. Also, the distance from the center of the dodecagon to each of its vertices is y. What is the integer closest to x minus y? All right, I'll just use the diagrams they gave me. I don't think I need to draw anything else. It might be a little small, but it should be okay. All right, so first let's draw a few lines here to figure out how to do this. Okay, so the first line I'm going to draw is something from the center to here, there, like that. Two such lines, and then that is quite small, so I'm going to have to actually draw it again. But that's basically what I'm trying to do. Now, if you continue to draw those lines, you'll notice that this octagon is basically 8 of those triangles, right? 1, 2, 3, 4, 5, 6, 7. Yeah. So the area, the A over 2 that they give us, is really 8 times each triangle, and I'll just call the triangles T. Well, actually, I call it T1. Yeah. And then these triangles I'll call T2. In a very similar way, the area here, which is also given as A over 2, would be, how many would there be? 12? 12 or 10? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 12 of those T2s. Okay. And then this area, well, that area is pretty straightforward. That's pi r squared. And they've actually given me that the radius is 3,000, so it'd be pi 3,000 squared. Okay, so that part's easy. The circle. Now what we have to do is we have to figure out what is the area of each of those triangles. Okay, so what I'll do is for the first one, I'll try to keep it in the same screen. So the first one, the T1, sorry, the T1, this guy, that we have to figure out this angle. So that, and this is x, that's x. So the angle would be 360 divided by 8, right? And 360 divided by 8 is 45. So 45 degrees is the angle there. And then T2, which is a little bit narrower, but it's got y and y, that angle would be 360 divided by 12, which is 30, right? So that's 30 right there. Let me just see if I can squeeze that in. That angle, this angle here. Okay, so that's very helpful because you guys should remember that in trigonometry, there's a way of figuring out the area of a triangle. So if you have a triangle like this, and this side is A, this side is B, and this is theta, the area is 1/2 A times B sine theta. Okay, so that's going to help us figure out this triangle. So let's revisit these two. The first one, a over 2 is equal to 8t1, but t1 we can figure out with this formula. It would be 1/2 times x sine 45. Correct? And then a2 would be 1/2 times y sine 30. All right. So that's actually very, very good progress, I think. So let's continue here. A over 2 is, well, that's going to be, hold on one second. 8 times x squared over 2, and then sine 45 is what? Root 2 over 2, I believe? Yeah. So we have a over 2 is equal to 4 root 2 x squared. Okay. That definitely helps, because we can, a actually is this guy, right? This is a. So we actually already know what a is, so then we can definitely figure out the value of x. Okay, that's very helpful. Let me do it the same thing over here. So this is going to be 1/2 y squared, and then sine 30 is 1/2. Yeah. So that's going to be a over 2 is y squared over 4. Yeah. And therefore, oh, I think I had, hold on, I think I missed, sorry, I missed that 12 there. Sorry about that. It's a good thing I caught it. Okay, so I got to multiply by that 12. So that's 3y squared. Okay, that's correct. All right, so now we just have to figure out the values of x and y, and then we can figure out this x minus y. So that shouldn't be too hard. Okay, so there's my first result, and there's my second result. All right, so now we have to plug in what a is. A is, it's up here, pi times 3,000 squared. All right, so I think we're going to probably need a calculator, and the good news is the calculators are allowed. So this is 3,000 squared times pi over 2 is equal to 4 root 2 x squared. Okay, so everything in here is a number except x. So you guys can crunch this out, not a problem. And I already did, and I got approximately 2235.12. Okay, and then in a very similar way, this one, the calculation for y, you can figure this out because y is the only thing that is an unknown. And when you do, you get y is equal to 2170.253, I believe. So now x minus y can be easily calculated, and it is 64.87, and they want the closest integer to that. So the closest integer to that would be 65. Rita is coloring a picture of a flower. She has already colored the center and the stem of the flower as shown. Next, she will color each of the 6 petals with exactly one of the colors: red, orange, yellow, and blue. No 2 neighboring petals can be the same color, and not all 4 colors need to be used. There are n different looking ways in which Rita can color the petals. What are the rightmost 2 digits of n? Well, let's start a systematic approach. Let's concentrate on one color. There's 3 colors, right? There's red, there's 4 colors, I believe. Red, orange, yellow, and blue. So let's concentrate on one color, and let's look at all the cases, and then at the end, n would basically be 4 times that, because the same scenario would hold true for the other 3. So if we find out how many cases there are for R, it would be identical number of cases for O, for Y, and for B. And then that would be our n, and then whatever n is, we take the last 2 digits. So whatever n is, we would take the last 2 digits, these guys, and that would be our answer. Okay, so here we go. So we are going to look at if we use red. Well, we can't use it 4 times because we have this very important rule. Where is it here? Here we go. No 2 neighboring petals can be the same color. So if I use red 4 times, there's no way for that to meet that requirement. So red can only be used maximum 3 times. Yeah. So I'll just draw the petals kind of like circles. Makes it easier for me. Like that. And then just connect them. So if we have red here, let me use the color red. Red here, and red here. Okay, that meets the requirement that no 2 neighboring petals can be the same color. And we have to figure out what about the other colors. We have 3 choices for here, 3 choices for here, and 3 choices for there. Those 3 choices are the O, Y, and B, the orange, the yellow, and blue. So this looks like a total of 3 times 3 times 3, which is 27. So 27 ways of arranging the coloring the petals when you use red 3 times. Okay, so that's scenario number 1. Scenario number 2, let's see if I can move this up just a little bit. Okay, scenario number 2 would be if I used red 2 times or twice. So let's see here, let's again draw those petals. And let's connect them. Okay, so first let me put in those reds. Oh, but there's going to be more than one way. Okay, this is interesting here. Because we can have red and red like that. Oh, I'm going to need more space then. Yeah, I'm going to need more space. Okay, or I can have red. Let's see here. 1, 2, 3, 4, 5, 6. And then I'm going to have, I need another one. 1, 2, 3, 4, 5, 6. Okay. All right, so that's one. The other one is top and bottom red, and the other one is top and a little bit to the right, I guess. So these are the scenarios. Now we got to figure out what about the other colors. All right, let's work our way through this. For this guy here, it looks like I can choose. Let me think about this. How many colors can I choose? How many colors can I use? I can probably use all 3 or no? Well, this one is a little bit easier, I think. You can have 3 possible choices there because anything can go there. You can put the O, the Y, or the B. But then these 3, I think I'm going to label them like A, B, and C, and then I'll just manually write them all out. I could write the numbers, but it might get a little bit confusing. So A, B, and C, using orange, blue, and yellow, I'm going to manually write them all the possibilities. O, Y, B, O, Y, O. Yeah. And that covers it. O, B, Y, O, B, O, O, Y, B. Yeah. And then if B is put first, B, O, Y, B, O, B, B, Y, O, and B, Y, B. And then if we put the Y first, I think we're going to have similarly 4 Y, O, B, Y, O, Y, and Y, B, O, and Y, B, Y. So 12. So let me see what is the... I have 3 possibilities for A. And then for B, we have only two possibilities because it can't be the same color as A, and it also cannot be R. And then for C, it cannot be R, and it cannot be the same color as B, so two possibilities. I got it. So if you do it by just by multiplication, it would be 3 times 3 times 2 times 2, which is 9 times 4, which is 36. Okay. Yeah, I wanted to explain it a little bit more thoroughly than just putting the numbers. So hopefully this kind of proves that you have 12 possibilities for A, B, C, and then you multiply by that 3 to get 36. Okay, this one identical, same philosophy, and this one in the middle, let's think about this one. There's 3 possibilities there. There's 3 possibilities there. Anything can go. But for these guys, there's only 2, because it cannot be this color and it cannot be red. So 3 times 3 times 2 times 2. Again, that's 9 times 4, which is 36. Okay, so we have to add up these guys, and when you do, you get 108. So 108 for the scenario when you have red as appearing twice. Okay, so then we only have one more left, which is red once. Okay, so let's figure that one out. Draw in my petals and connect them. Okay, and then we put in the red. Put in the red anywhere. Okay, now let's talk about this here. So, well, for this one, I have 3 choices. For this one, I have 3 choices. For this one, I believe I have only 2 choices because it cannot be red and it cannot be this color, whatever color that is, correct? So that same kind of philosophy there. And then for this one, it cannot be red, cannot be this color, and it cannot be that color. Yeah. Actually, let me go back here. I think one of these 3s is not correct. Let me go in a clockwise. Yeah. So I'm pretty sure that's correct. And then for this one, it cannot be this color and it cannot be red. So we have 2 choices. So I'm confident about that. For this guy here now, it cannot be red and it cannot be this color. So that's 2 choices. For this guy, again, it cannot be red and it cannot be this color. So 2 choices. And then for the last one, it cannot be red and it cannot be this color. So 2 choices again. Okay, I think that is the right way. So that would be 3 times 2 times 2 times 2 times 2. And that is 4 times 4, 16, so 48. All right. So we got that 27, this 108, and this 48. So that's 183. But keep in mind, this was our calculation for the red. You can go through this entire scenario, all these scenarios, identical calculations for the other 4 colors, for the orange, for the yellow, and for the B. So remember I said you'd have to multiply by 4. Well, the number we got was 183. So that's what goes in the bracket. Then you multiply by 4 because you'd have 183 for red, 183 for orange, 183 for yellow, and 183 such cases for the blue. And 4 times 183 is 732. And they wanted the rightmost 2 digits, which are 3 and 2. And 32 would be the answer.